Well, welcome, and thank you for your interest in the BDE libraries. Who here has already seen them at all? Maybe on GitHub a little bit? Some. Who is familiar with the works of John Lakos? Very good. So, just get started. In case you hadn't heard of, first of all, what is BDE? My name is Steve Breitstein. I've been working for John for 10 years now, and before that I did other stuff that I can't remember anymore.
10, Steve.
Going on 12, actually. So I joined the BDE team, about 11 and a half years ago. So just the first matter, what is BDE? What does it stand for? And the answer is we don't really know. You will see written some places Bloomberg Development Environment. Sometimes you'll see the Basic Development Environment, and some wise guy suggested that it is the BDE Development Environment. Yes, that is recursive. So it means what it means. The term can be applied to the libraries that we're about to examine, to the team, about 10 to 12 people, about average over the last 10 years, many of whom are here today. And the methodology, which was inspired by John Lakos, based on his book. Who's read this? Well, raise your hand, John.
Captured it for posterity.
And subsequent work, talks, such as one that's available through Pearson called Live Lessons, and several talks here at CppCon the last 3 years, including one yesterday. Okay, and further work going into his new book, coming out in current year +1 for many years now. Okay. We call these the classes provided by BDE are sometimes called foundation classes because they're generally not customer-facing code. This is code that is for building infrastructure. Several layers up, you finally get to the level where Bloomberg customers are interacting with the software. You can find it at that GitHub link. It is currently about 900 documented and tested components, organized into 47 packages and 5 package groups, where a package group gets released as a library, something we call a unit of release, UOR. The kind of problems solved by these libraries tend to be those that are best done once for the enterprise, such as the definition of date and time, classes, calendar types, and utilities operating on those, logging systems. I don't know how many logging systems one typically has in an enterprise. I found many over lifetimes. In different projects, I'll find different people are using 3 types or 4 types of loggers through the same code body. We're trying to resolve that problem. We have one very good logger subject to an hour talk, at least, by itself. Other things such as command line parsing, a great tokenizer, almost called the tokenator, threat management, data marshaling, networking, more things. These are just the highlights that I jotted down as I was perusing the libraries. So as you can see, there are many areas of applications addressed by these libraries. They are all component-based. That means they are all levelized. There are no cycles of dependency between these components. Moreover, the classes that are implemented fall into a system of classes, a class taxonomy, which we'll look at more in a moment. They are abundantly and detailed and consistently documented. They feature narrow contracts And to help with the narrow contracts, we have defensive programming features. All of the types that allocate memory are equipped to accept runtime polymorphic memory allocators, including our version of the standard library. So, our vectors, our classes, our hash, our maps and lists and strings all are allocator enabled. Lastly, you will find that everything is thoroughly tested. Each component has a test driver whose responsibility is to prove beyond all reasonable doubt the component meets its contracts, plus more. And these are published, and we invite you to peruse them. Okay, so just in case somebody hasn't been through this before, what is a component? It is, an example would be BDLT date. That is a component whose major class is date, that is implemented in the BDLT namespace. And furthermore, all the classes are also, they're further wrapped by the Bloomberg namespace so that we can mix with third-party code without fear of collision. Okay, the component consists of two files, an implementation file, the CPP, and a header file, which the interfaces and inline implementations are defined. Okay, there are always two. We have no standalone .h files. It's just simpler that way. And I said earlier, there is a test driver for this and for every component. Components are more than a pair of files, .h, .cpp. There are rules for writing components. Specifically, one, the CPP has to include the .h first. Why is that? Anybody? Yes, ensure that that the H file is self-sufficient. That you don't have you need no other includes. And basically 2 and 3 are saying that everything related to this class can be found in the component. Okay? If it's implemented, you'll find the interface for it in the header file. If it's in the header file, if it's defined in the header file, it's implemented here. You don't have to go look anyplace else. This component handles everything having to do with the classes. Furthermore, that any components it uses are accessed through their header files, and everything. And our clients of this will include header files, so we can examine the header files and determine the physical, the physical dependencies. There are no, and extern is disallowed. Because that would be a way of accessing something without having specified said it loudly, without it saying it very loudly and explicitly through a .h include. There are two major design rules: that there should be no cyclic dependencies between components. Any logical dependencies between classes have to be within the component, and even then those are frowned upon, because having cyclic dependencies complicates testing. And any friendship between classes has to be contained within the component. Questions? Yes?
Are these somehow enforced?
By review, by some tools. The cyclic dependencies are enforced by tools, according to that. Every once in a while we'll find a problem, but it's very rare. It's like, I haven't seen one of those for a while. So we're usually pretty good about avoiding them, but yes? BDE Verify does that? Oh, I encountered otherwise. Oh, and the question was, are there tools to enforce that? Thank you for that reminder. Yes. Okay. So now we know a component. Components are organized into packages. Packages are related components. They have the same envelope of dependencies. They have related functionality. So that in addition to date, we will also have a date time, a date util. Utilities being operations on date that don't really require access to the innards of dates. So if in order to do something with date, if you can do it through the public interface, put it in a utility. Keep date simpler. And time and others. And as you can see, that they all have a common prefix. They all declare their symbols in the same namespace. And surprise, you'll find them all under a directory called BDLT. And that says pretty much what I just said. Packages are further organized into package groups. So the BDL package group contains BDLT and others. And what distinguishes a package group is the first three letters of the package name. So, and one consequence of that is that when you design a package, you have to know where it's going. You have to study, you have to know what its dependencies will be. You'll have to know where it's going to fit into the overall software hierarchy so that you know how to name it. Again, no cyclic dependencies among any of the packages. These define a library. So this is something you'll see on your link line. And you have, in case you're wondering, that's what the suffixes stand for. And this has all been said. And lastly, now that we have our libraries, what are the libraries available to you? There are these five rather. Val, which has fairly high-level libraries. This is where we have our logging system, our metric system, stack utilities, our time zone systems. Okay. Yes.
What do you mean exactly when you said stack utilities?
We have a set of utilities that will analyze stacks, the process stacks. Process stacks. Sorry, that was a good question. And it is and it's very useful sometime. We'll see later on. Okay. This is a fairly small package group. It has some business logic in it. It has day counting conventions, something you could imagine being useful at Bloomberg. BDL is a fairly large package. It includes specialized containers, other packages for encoding and hashing, various utilities on the fundamental types, memory allocators, and date and time. BDLT, for example. BSL, Bloomberg Standard Library, contains our allocator-enabled containers and allocators and a whole suite of utilities and components that go into building a library, which are available for everyone to use. Okay. And BDLT is a package group that is, it's labeled not recommended for use. It's something there it's there, you'll see it. It is there as a requirement by some other library. Nevertheless, I've heard that it does have some very useful components in there for managing bandwidth. So you might want to take a look at those. As I said, there are no cycles between the components, between the packages or the package groups. This is what the hierarchy is. At the very bottom, we have compilers and linkers, then our standard libraries, then more heavier fundamental libraries, and then what you could consider relatively speaking, application libraries, things closer to applications. That's, and then so it's spread out. Now, our goal for today is to help you find your way through BDE, the documentation and other resources that are available to you so that you can get started, to give you a feel for programming within narrow contracts and how to engage our defensive programming techniques, and generally to try to convey to you the BDE mindset. So if you are going to work with this, we want to get you thinking, set your expectations so that your barriers to getting involved are reduced. I should add now that this material derives from training materials that are used for senior hires at Bloomberg. Senior hires, people with several years of experience, have extensive training on technologies of which they can't possibly be familiar prior to arriving at Bloomberg. And one of the things is that they get like 10% of their time goes into BDE. They spend time listening to John's lectures, and they go through some material, lab-based course. This material has been adapted from that. So this has been proven successful for getting people on board to BDE. Documentation, you can find it at GitHub, where you'll find links to tutorials, our coding standard, 50-ish pages, and not enough detail. There's still many rules that are not there, that are not written down. How to contribute, I hope you do. Build instructions, and a link to our online documentation, the DOXYGEN pages. Is everyone familiar with DOXYGEN? Okay, so another thing that you'll find there is the taxonomy of classes, because classes are not just, invented on the fly. There are various categories of classes, each having a well-defined organization, certain expectations of methods, certain common naming conventions, so that when people design classes, they will find the appropriate place for this. For example, there is a value-semantic class. Anyone tell me what that means? Anybody who's been through John's? Yeah. So, class that defines a value. Value being a concept that's a reserved word. An idea that can preserve its meaning across processes and different machines. Conceptually, if you serialize it and recreate it someplace else and the meaning has not changed, you're probably working with a value. Other classes create objects that have state but no value. Those are termed mechanisms. Okay.
Can you give an example?
Of a mechanism?
Yeah.
Example of a mechanism would be something like a memory allocator, something that manages memory in this process, something that manages database connections, socket connections, a guard that's standing by to destroy an object on destruction, Okay. Thread pools. Thank you, John. Okay. Utilities are the name we use for components that provide stateless functions. Because not everything in C++ is an object. And those are those. Actually, they are implemented as structs for, pardon? With static methods, yes. The advantage of that being that there's only one place where you can define them. Namespaces can be opened from many places in the code, whereas a struct is only defined in one place, and that's what we want.
There are 7 reasons that is not the most important.
All right. And Which is the most important, John?
Probably because that's the way I want it. Seriously, the real reason is we want to deal with functions as a unit about the same size as classes. And if we were to deal with individual functions in a namespace, we have to deal with them as individual units. We want to have equal size things compared.
So it's a convenience of aggregation.
Again, that's probably the most important reason. As I said, there are 5 more, but just go ahead.
Okay, John. Moving on. There are also classes that define protocols, which is a term that basically pure virtual, a class that has pure virtual methods, pure, no implementation, so something that can't be instantiated. So these are bits of BDE terminology, and these are used throughout the documentation. And so the expectation is that when you read, that when you're reading them, you have expectations about what each one of these are. And we'll look at some of these in more detail later. Here are some examples, though. So value-semantic classes are date, day of week, date time, calendar. By the way, calendar here means something different than what you heard in my chrono talk. Okay. Allocators are mechanisms. Utilities are utilities, by the way, and often they're named util, but not always. As you can see, there's something called current time, which is a utility that is not named that way. Okay. If you get to our documentation, you will find, you'll get to a page that looks more or less like this. Is that readable? Barely, all right. What people often do is they will expand, hit the button to say expand all and do search for things that are of interest to them. Here we did a search for date, and we can see the date is part of the BDLT group package and part of the BDL group. The things circled on the left are all links. So for example, if you click on BDLT, you'll get a view of that entire package. We'll list all the components in it. We'll show the hierarchy of the components. So you have, like you can see over here, that this says 24 components having 7 levels of physical dependency. And so if you wish to study this package, you might want to start from the bottom on things that have no dependencies in this package. And then those are building blocks for the next level and the next level and so forth. Okay, there's also usage examples. If you click on the link to the component doc, you'll get the component doc, where we'll see that there is a purpose line, always a sentence, almost always starting with the word provide. We'll have a list of classes. In this case, there is one. If there are multiple classes defined in the component, others will be listed here. There might be other classes. In the component, there might be classes. There might be classes solely for implementation. Okay. And there's a certain naming convention so that people know not to use those directly. But the simple rule is, if you see the class listed under classes, then you're allowed to use it. And if you find some other class in there that you're trying to use and it changes, it's, you don't have much of a defense if that changes. We have lengthy descriptions. That's a link to get down to class level documentation. And this is getting rather, this is about as far as we're going to go here because I find it really hard to read this. As you can see, I had to, the actual pages are way too big to fit on the screen. So I had to just sort of tear it up into pieces just so that you have enough there so you could recognize them when you get to it. I find it actually, as though it's hard to look at source code on the screen. I It's actually better in this case than trying to look at those generated pages. This is where all the doc comes from. It's all embedded in the header files. Divided into sections. There's our purpose line. Again, one line, and the line can't be more than 79 columns. Really?
Including the //
Yes, including the // No line of code is more than 79. So it makes us, it can be challenging to be expressive in that small space. Okay. Again, there's our date, the class that we're allowed to use. See also, and the description is self-evident, there's also a usage example that typically have pedagogical asserts. That's to say, we don't actually expect somebody to be default constructing a date and then asserting to see that it was done correctly. That's just there to, just as a comment. This is all the usage examples are tested. One of the responsibility of the test driver is to mechanically reproduce the usage example and show that it works correctly. Okay. For each, so all that information is describing the component as a whole, describing if there are several classes in a component, describing the relationship between those classes. Per each class, you'll find some additional documentation. Typically, it reproduces some of the things said earlier in the component level. But what you'll find here are, any invariants for a class that you should know, are expressed over here. Some things are tacitly guaranteed for the class, even though they were not mentioned in that description. So unless you hear otherwise, you can assume that the methods of the class are const thread safe. And by that we mean that if you have multiple threads accessing an object of the class, that is perfectly safe as long as they restrict their activities to the const qualified methods. Okay. That the methods are exception agnostic, to be defined shortly, that things are alias safe if that's pertinent. And this is all true for, backing up, for this class, even though we did not say it. Okay, so this is one example of, despite our heavyweight documentation, there are certain things that are tacitly assumed, have to be known by the reader. These particular terms are defined by the glossary, and if there are stronger or weaker guarantees for a particular class or particular method, those will be called out fairly emphatically. Regarding exceptions, exception agnostic is a term that means encompasses several things. One thing you get out of exception agnosticism is the basic exception safety guarantee. That is, in case an exception is thrown, it is the object will be left in a valid state. You have exception neutrality, in that if exceptions will pass through our methods without interference. So if one of our components calls something, which calls something, which calls something, which throws an exception, that exception will not be caught and stopped. It will not be modified. It just flows through, so you can count on that. And lastly is sort of an implementation detail. BDE implements this exception safety by using an RAI-like technique. We avoid try and catch blocks. We use proctors, which are guards that have release methods, and so that this code works very well. It will depend. You can build it with exceptions or not exceptions. It just works. BDE code does not throw exceptions. It's not in our programming model, except where it's required by the standard. So we have implementations of containers, and containers are required to throw exceptions at certain times. And and so they do, such as bad alloc from a memory allocator. Exceptions, we throw many exceptions in our test drivers, because when we say things are exception safe, it's not because we looked at it and said, hey, that looks safe, but we run tests on that to confirm that they are safe. And if we don't throw exceptions, where do they come from? Well, they could come from legacy code, which other code at Bloomberg, sometimes there are BDE classes that wrap other Bloomberg methods that could throw exceptions. So anybody depending on them will get them. And also, we are some interfaces where we take user level, callbacks that might throw exceptions. So that's where they come from. Lastly, we have next level of documentation is the function level the documentation for each of the methods of the class. The methods of the class are usually organized per the banners that you see here. We have class methods first, the static functions, then creators, which include all the constructors and the destructor. Manipulators are methods that may change the state of the object. Accessors are const qualified. They are guaranteed not to change the state of the object. Always in that order. And if you're navigating our code, it's worth remembering, because that helps you find your way around. There is a legalistic tone to the documentation that you find here. They're very terse. It's terse. Notice it comes after the method signature. We assume you read the method, you know what the arguments are, you know what the return type is, so we don't have to repeat that information. Okay. And there's a certain pattern. Return true, create a date, assign to, load, into, okay? So these are always, gentlemen? So we have a dead regular form for writing this documentation. It's always first thing we say is what the function does. It's always a verb. It's done in the imperative mood, as if you, the reader, are commanding, you who are invoking the method are commanding the object to do something. You will set, or you will load, or you will create, or destroy, or so forth. Okay? The next thing you will find what the function returns. And in some cases, the two convolve. If all the method does is return something, well, that's what it does. Any other optional arguments or any are discussed next. All other essential behavior is listed after that. And there I urge you to be careful and read what is the actual described essential behavior. Okay, it may be different. Do not rely on observed behavior. Sometimes you will say, "Oh, the method didn't say what it does in these circumstances, but I ran some tests and I found it does X, Y, or Z, so I'll depend on that." Okay, in that case, you'll be in trouble if that changes. Only the explicitly listed behavior is something you can rely upon. Next, conditions leading to undefined behavior. So the preconditions for the method. And lastly, clarifications. Note that. Now, in general, note that means that note that is something that will tell you what is something, pay extra attention to this. Here it means to clarify. might be the better way to say it, except we have a lot of doc that says note that. So note that's are not normative. You will not learn anything new about the contract in the note that, but it's an opportunity for the author to try to explain something that might not have been obvious. Lastly, we have a convention that the first time a parameter name is mentioned, we introduce the expression the specified. So just going back for a moment, return true if the specified year, month, and day, and so forth. The specified right-hand side date, which is, I take that as a clue to go back and check, shift my eyes up and see what type that parameter is. Questions here?
I have a question.
Sure.
What happens after you've specified it the first time? How do you treat it subsequently?
You do not say the specified.
So it becomes a proper noun.
Correct. Okay. Let's go back and look at our component level doc again. Provide a value-semantic type to date. The class is a value-semantic date type. This component defines a value-semantic class. Does the author of this page, John Lakos, by the way, expect you to know what a value-semantic class is? Yes. Which is why we'll spend time to discuss what goes into that. Briefly, value-semantic types are ones that represent a value that have regular type syntax, a la Alex Stepanov, that have a reasonable operator, have a operator equal that compares those things. So those are the characteristics of a value-semantic class. Typically, you will find methods: default constructor, value constructor, where you can specify the attributes of the class to bring it into the state that you want, copy constructor. Okay, no surprises. Assignment, equal, of course, not equal, and getters or setters of different, though we don't use that terminology. Okay, you'll also find a print method for these classes. So that this is there for debugging purposes and for testing purposes. It has a rather lengthy contract, which very few people read. But the key points are that it's going to print the value in some unspecified human-readable form, and it is subject to change. And do not write parsers for this, because it's subject to change. If you want something in a different format, you do that yourself. This is print methods are really not part of the value class. Okay, there are a million ways to print a date, and the more will be thought of every day. We're not going to encumber the date class with that. The job of the date class is to represent a date value. And of course, since one of these things happened to have changed in the last release, and of course there was a brouhaha about it, and the fact that we kept, we pointed out the contract really didn't protect us very much. All right, so having discussed some of the things about date as a value-semantic type, a date operator, date itself, you can increment the date, you can do fancy arithmetic on the date, you can compare dates, you can set date values. These are things that are specific to dates. There are other value-semantic classes that are not so complicated. They just hold, values and don't provide any operators. And if you go back to the taxonomy, you'll find that under value-semantic types, there are various subcategories of value-semantic types. Okay, and sometimes that terminology will creep into the documentation. The date value itself represents dates in the range 1 from of year 1, month 1, day 1 to New Year's Eve of the year 10,000, except for some days in 1752 when the English-speaking world switched from the Julian calendar to the Gregorian calendar, which is kind of odd, but that is a POSIX standard. There is code there to support proleptic Gregorian dates. You are allowed to use them. We at Bloomberg are not, having started using the other kind. Methods are provided. So basically a date is represented by integers. Year, month, and day, or year, day, and year. How do you know which combinations of integers you can put into a class? There are static methods provided to tell you whether they are valid or not. So, just using it. Default constructed date. What is the default value of a date? Somebody? Pardon? Epoch? No, read it. Default constructed date is 111. Year 1, month 1, day 1. Okay? Having a date, we can set the year, month, and date. Okay? 3 integers, year, month, and date. Be careful of the order. What happens if you do this? Americans like to put the month first. 15 minutes to go. And 20 slides. Should be good. Thank you. So be careful of the order. What happens in this case? There is no status. It's a method. It returns void. Undefined. What's the undefined behavior again?
Anything could happen. You're out of contract.
You're out of contract. Thank you. Okay, though we've... Yes. That'll be really unexpected. Okay? Undefined behavior is one of the features of BDE code. Okay? There is a class of library design that say that the user should not be allowed to make any errors. This is not that. If you know that, if you know you're putting a good date, there are no checks. If you're not certain, if you want validation, which is not trivial, then you use the if valid method. Or you can just take invoke the static method directly, and hopefully you copy the values correctly down to and create your date object. Date arithmetic is you can increment, you can change things by, you can advance the date by 1 day, advance it by 3 days. The difference of dates is an integer value. And just FYI, the first lab for this course, when we have a lab, is to have everybody just calculate how old they are in days. They seem to get a kick out of that. Of course, they're a lot younger than I am. Okay, more on narrow contracts now. Narrow contracts place preconditions on the input parameters, our object state. We state those very clearly. Okay? And it's a very common feature of BDE code. And if you don't find any such preconditions, then it's a wide contract. You can put in any values that the parameters can hold. Here's an example. Highlighted in red. Create a date. You can use any year, month, and day. Behavior is undefined unless those things would return true by is valid year, month, and day. Oh, by the way, note that the strong convention that methods that return a Boolean start with is or has or something like that, so it reads reasonably well. Operator plus plus is an almost completely wide calendar. You can always increment the date unless you're on the last date it is supported. So do not try to go past New Year's Eve of the year 10,000. And of course, setting year, month, and date will always be bad if year of day is more than 366.
Is your undefined behavior gracious enough to fail under a sanitizer?
More on that in a moment. Okay, I don't know if we have things to help people, but whether or not that is,
The answer is no.
it might be what he calls a sanitizer. The defensive program might be his.
Human being, yes, otherwise no.
Okay. All right. Anyway, key concept, preconditions are met. Everything that worked by contract. We rarely get a bug report saying you do not meet your contract. Maybe once a year. And that's on like 1,000 components. Otherwise, anything can happen. This has been discussed at other places and other times, other talks over here. Anything, of course, there's no, except for the absurd. Can change over the time. In our view, if you've entered undefined behavior, your entire process is corrupt. I mean, a path of execution that got you into undefined behavior meant that your program went bad upstream. So this is not something you try to recover from. By the way, when you say anything can happen, there's a subtle one. Sometimes it works as you expected it to work. That could happen, and that might change someday, and people get very upset. Okay. Over here, we have a contract load into the specified year and day of year, the respective year and day of year attributes of this date. Does the contract say year, either of those pointers have to be non-zero? Could they be zero? Okay. Contract doesn't say anything, but the tacit assumption is that those are valid pointers. They are not zero. They're also not 1, 2, 12, other values that are probably not good addresses. They have to be good addresses. In this case, they have to be writable. They have to be aligned. They have to, if they're pointing to non-fundamental types, if they're pointing to an object, we assume that if you give me the address of a string, we're going to assume there's a string there. Okay? Checking for that is hard. Yes, sir. References are not as safe as people think. They. Mm-hmm.
No, they cannot is undefined behavior.
Okay. Can we? I'm under a little time pressure. Can we take that up off a hand?
More than happy to talk to him afterwards.
I know what to say. I just don't have time to say it now.
Okay, go ahead.
Okay.
I'll talk to him afterwards.
Okay then. So there are tacit assumptions about pointers. And it's too much to say that every single time. So yeah. Okay. It is easy to slip into undefined behavior. What's wrong with line 1? Pardon? Invalid date. But easy to think. I mean, 3 in values tend to be default to 0. Yep. What's wrong with the second line?
Yeah, you're underflow.
Underflow, yes. Default constructed date, decremented. You didn't see the method for that, but extrapolating from what you saw about plus plus. What is wrong with number 3? Okay. Not that many years in the entire calendar. Not that many days. It's not that large a number. If you have a function that is returning an int and then you're going to be adding it to a date.
Okay, so you're.
Yeah. So it's you want to be careful about that. And of course 367 is always bad. Okay, what's wrong with this guy? A little bit more subtle. Load to the specified result. The earliest date of interest between the specified first and last dates inclusive. Return 0 on a success and non-zero value otherwise. The behavior is undefined unless first is less than or equal to last. Why is the test wrong?
Because it doesn't catch the case where first is equal to last.
Last should be out of the scope of the scope of the date, which is impossible due to that behavior.
First is equal to, first, it doesn't work? Oh, you're right, that is a bug. The bug I was thinking about was that last could be, if you're depending upon date exceeding last for the loop to end, you're going to be in trouble if last is, 99991, something that will rarely come up, but it could. So you don't want to have to count on date achieving a value past 999/1231.
You can't use this to match something that might where last is equal. You can't match up with 12319999 either.
Okay.
Because you'll never get there doing less than.
Okay.
You can never include
Do that date. Yes. Okay, this is buggier than I thought.
But in practice, it's not going to matter.
And the point is that that this is an idiom that is, people typically, we write from this till you go past your limit, and this is what people reflexively do, but it could be bad in these cases. Also, if you don't meet the prerequisite here, you could possibly get into bad things happen. So let's just go on to there. So, just a commentary on language. People will say that, we'll say things like valid date object and invalid date object. That really is, the first one is redundant and the second one is contradictory. If you have a date object, you assume it's valid. We don't check when we copy, we don't check when we assign them. Okay? It turns out that's a rather hard concept for many people to get. The students I have will often seem to think you can have a object in an invalid, you can badly construct an object and somehow look at it and fix it up. Like everything's still going to work. Okay, anyway, since defensive programming within these contracts can be challenging, though one can argue whether that's more so than dealing with pointers or dealing with integer overflow and other things that we trust people to do. So BDE code has compile time conditional assertion checks built in when it is possible or practical. These are not part of the contract. So this is just part of what we call quality of implementation, details. Okay? So we're not promising this, but because we want to help you, where possible, we'll put these things in. They're done using a system of macros invented by Mr. Lakos here. Excuse me, Dr. Lakos. Okay. Dr. Lakos. Okay. All right, here's an example of how they might be used. Behavior, blah, 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 long contract. Behavior is undefined unless the target date is in the range of calendar, where calendar here is something that a class that we have that maintains a range of dates and that can be adorned with information about which days are holidays and which days are weekend days and so forth. Okay, so what you'll find is that we will do a limited check on the validity of free date. We'll check to see whether it is 0 or not. And it happens to be invalid to invoke is in range on the calendar object unless the range is greater than 0. So we first check to see it's okay to run the method, and then we check to see whether the target date is in range. Now what? Why didn't we just use ASSERT? Somebody once asked me recently. Well, these are better in two ways. One, we have finer control over which of these assertions, with asserts, they're either on or off. Here we have different categories of checks that are key to the computational weight of the check. And we have freedom as to what happens when an assertion fails. So normally for an assert, we'll use the assert macro, the unadorned assert macro, when the overhead is roughly 5 to 10% of the method call. If something is heavier than that, we'll call that assert safe, a different macro that can be turned on or off separately. And these are, you'll see these these commonly appear in inline methods because inline methods are so short and so fast that any check is going to double the cost of a method call. So they get categorized as safe. And lastly, we have another category for for checks that you want to do even in optimized mode. Now, the library developer, the person who writes the code, will put in the checks and categorize them according to their weight. The application builder decides what is the appropriate level of defensive checking. So, two separate independent responsibilities. This table give you some idea of how to turn them on. It's essentially, if you set the flag BSL assert _level _assert safe, you'll get them all turned on. The default is the second column, the second row, where the safes are off and the others are on, and optimized build modes, you'll have all the ops. And you can turn them all off. And there are other combinations if you want to. These are the ones that are commonly used. Personally, I always develop with assert safe on. Why not? Okay, and if you're doing WAF builds as instructed at our GitHub site, you use the safe option to WAF configure, and more details at that link you see there. Lastly, the last level of freedom is what happens when an assertion fails. Well, that happens at runtime. Whoever is starting up the program is going to determine what happens when assertion fails. And this is something you can programmatically change over the course of a process lifetime. The default handler does an abort. So we have our same behavior that we have, the one that we know from the classic assert. Second method, we'll sleep, so that you can then go over and examine the live process with a debugger, just while it's still in memory. There's also a method called fail throw, which throws that particular exception, which will give you an opportunity to do a safe shutdown. Remember, this is something if you have gotten into the situation where you've entered undefined behavior, you've got a process that is suspect. Why is it trying to do something so bad? So, best policy is to just try to shut it down safely, rather than continue and try to make mistakes, especially, if you're in an important application. Of course, whose application is not important? So, now, there is an option to log the exception and then continue into the undefined behavior. And this is something we use when we have working code that's making money, but we want to encourage people to instrument their code with these assertions. So this is a way we can discover problems in existing code without causing interrupts to clients. And one more slide, please. Just a summary. So the libraries, I assert and hope I've convinced you that these provide wide utility. The documentation is clear, complete, very regular. Having a well-defined taxonomy aids in comprehension, and using narrow contracts without forcing checks where they're not necessary leads to efficient programs if you use them correctly and use them responsibly and can be handled by seasoned developers with appropriate training. Okay. Any questions? Okay. You were first.
So you have a set of very strict rules about developing new functions and so on. I can assume that the team working on BDE is relatively small, but do you also enforce the same rules on the applications that are developed on top of BDE? And so how do you manage to do it in a wider range of people, or if no, why not?
We have little control over people outside of BDE. By the way, the question is, do we enforce our rules on everybody else in Bloomberg? If only we could. But it's a matter, we lead by moral authority, answering questions, giving classes. Many people many of the managers at Bloomberg are proteges of John, who have learned under him and agree with many of his methods, and so it has proliferated. Different degrees of strictness are applied in different levels. The BDE methodology is very time intensive, and it is justified by the fact that we are writing code at the bottom of the software stack that's going to be reused very heavily. So, not people that are higher up the stack can't make that same they have to cut corners. We understand that.
I'm going to have to call time. We're out of time. So,
Oh,
if you want to, talk offline, but it's.
Yeah, that's fine.
all right. I'm sorry I didn't get to your question.
How long does it take to create and support documentation, percentage of all development time?
We spend about half our time on doc, half on testing, half on development, half on design. It's a lot. Thank you.